welcome you once again to this panel discussion. It's a general question for you all. In the current changing context and in increasing infrastructure spendings, what expectations do you have out of intelligent MEP planning for sustainable HVAC to result in data-driven buildings of today?
Not today, but it is forever. Like, you'll have to reduce your energy footprint. The consumption of the system should reduce, and that will be achieved by, proper, I'll say smart is also definitely there, but proper design. So
Mhm.
integration with the help of technology, integrating various IoT devices, yeah, your AI generative models, you can definitely achieve. But your design should be such that it is reducing footprint, energy footprint, because ultimately it will reduce carbon footprint. We can achieve net zero. Everything will depend on that. So emphasis should be on the energy saving sustainable design.
That's quite valuable insights. Mr. Anant, would you add on to it?
Uh, Whenever the infrastructure, when infrastructure of the infrastructure is upgrading or zoning, the IoT system is a very important for the infrastructure to upgrade the system, existing HVAC system. That is the very helpful for the MEP design.
Okay, thank you for that response. Coming to Mr. Dipak Babrekar.
See, infrastructure is rising everywhere, means may not in India, it's a globally. Okay. So we are having this kind of like metro stations are coming. You are some smart cities which are underground metros are coming. So where the problem of the safety, comfort, and your integration of the prediction that is happening all over. So you have to take the MEP a smart integration along with the your conventional MEP design. I will. What is our main goal is to reduce the carbon footprints. See, we are even if you save the 1 kWh, okay, 1 unit, okay, we are taking the load from the nuclear power where we are generating the power. So if some person, if he is consuming 10 units and saving 2 units, that will help not only to the himself, but it will be a global issue that is our carbon footprint, because whatever you are consuming, that is going to make the carbon footprints also. It is going to increase that. And our main goal is to reduce the carbon footprint. And this technology, which is maybe digital twins, even artificial intelligence and IoT sensors, what they are doing is we are not saving with from the point of view, but we are saving the wastage energy. That like suppose we are so there is a no person is sitting in the room, that room, still that HU room, unit is working on. That can be that energy can be saved with the help of occupancy sensors, even your lighting sensors. So that is whatever energy that is going wasted, that is we are saving with this kind of technologies. And one of the basic thing that is which help is that prediction that is not coming with your normal conventional system. So these kind of things, I think there is a future, and we must implement all these kind of MEP integrations for the smart HVAC.
Yes, definitely. Mr. Deepak, reducing carbon footprint, that is the main point which Mr. Indravadan also mentioned. Mr. Indravadan, there is a question from the in the Q&A box. What are the other softwares apart from HAP you have used?
Popularly E20 and HAP are the two popular tool which is being used in the industry. So these are the two tools we regularly use. For normal projects, we use E20. Okay. And for the complex calculation and everything, we use HAP. Sometime we use other simulation methods. We take help from green building consultant to calculate the envelope load and everything. So I don't know what software they are using, but envelope heat gain calculation we take it from green building consultant.
What's the main objective of HAP software?
See, you are getting precise data. Your hourly, as the name suggests, hourly analysis program. So
Okay.
365 days hourly analysis you can do, which is the time when your HVAC system is consuming or heat load is on peak, which is the time where your heat load is at minimum level. So, with this precise data, you can get it for 365 days starting from Jan to December. So ideally, we take July data as a benchmark because it is a peak load condition.
Okay. While you were talking about in your presentation about the data-driven MEP designs, energy cost, and real-time data. So how does real-time monitoring and predictive maintenance enabled by smart data-driven MEP design reduces operational cost and downtime in HVAC?
I have
And
make one tagline. Sorry, please.
hello, shall I repeat it for you?
Yeah, please, please.
How does real-time monitoring and predictive maintenance enabled by data-driven MEP design reduce operational cost and downtime in HVAC system? And second link to it is how ventilation can be improved with design.
Well, see, I have made one tagline.
Correct.
Last 5 years, I'm using it. If you can monitor it, you can conserve it. See, earlier
Okay.
we didn't have that much, technology. With that, we can monitor our day-to-day power consumption, or nowadays with the IoT sensors, even you can monitor your air quality. Okay, foreign particle content and everything. Earlier, we didn't have that, technology easily available in India. So that was the time we couldn't even monitor what is happening with our system. My HU, I have installed 10 year back. What is the power is consuming right now? I didn't have that data, right? What is the power my chiller is consuming? So with this advanced technology, smart designs, now we are able to know the real time data. My rated say chiller capacity is consumption is 100 kW, and now it is taking 120 kW, right? So that is possible because of after introducing the smart technology, sensors, and everything. So definitely now since I'm monitoring it, I came to know that it is 120 kilowatt is consuming, means there is something not right with the system. So I'll go and check. Okay, earlier we didn't have this liberty. Now see, even I can say if I'm talking about my clean room, I can measure the foreign particle. We have the thousands of or hundreds of sensors installed within the clean room. So we can monitor the air quality also. Earlier, this I think the senior person must throw light on this. We literally have to go in the clean room. We have to measure the with different location. We used to measure the air particle. What is the air particle? That used to happen once in a year when audit is coming. Now it is a day to day. You can monitor it on your screen. So what is the air particle? So definitely the smart technology and this all we could have achieved, we can achieve with advanced planning only. HVAC system. We have used wind tower. It is an auditorium building. So two wind towers we have used. The same one which is I think done in CIA Godrej Hyderabad building. The pre-cooled air is passing through the wind tower, okay, and entered in the air-conditioned area. So itself is they are we are minimizing the cooling capacity required for the fresh air, because auditorium requires 30 air change, 20 air change depending upon the requirement of the client or regulations. So that amount I'm already entering in the building pre-cooled air. So I'm reducing energy footprint here again. I'm reducing my HVAC load. So the whole idea is your energy consumption, your energy footprint should reduce. Your energy consumption, if you are reducing, ultimately you are achieving your carbon footprint also, net zero concepts also, digital twin, whatever you say. So method could be different, but the bottom line should be your design should be sustainable, and that is the only should be the goal. Second, from consultant perspective, I'll say, uh, see, over design is one of the major challenge in the industry. Whenever you are over designing the system, Means you are not sure you are not confident on your design whether it will perform or not. So with this data driven approach, you can gain that confidence. My design is perfect. I can achieve whatever goal I'm carrying for the project, right? So I think that should be the approach, and that is the bottom line for me.
Advanced data analytics can optimize HVAC performance through design.
Like CFD, computer fluid dynamics. It is the whenever chilled water system, chilled water HVAC system. There is a chilled water is flowing, very chilled, or what is condenser, or all this. They're optimizing the LS cost saving. So whenever the cost is higher side for chilling the water, for chilled water system, there is a CFD model you can utilize, and they save the cost, and to reduce the just Indravadan sir says ki at the evening time to condense chilled water, chilling water the system. After the it will be efficient to the smarter chill system.
Okay, thank you for sharing those views. Now coming to Mr. Shailen. So you gave an example about the Unilever, lighting and other things you saved on the energy. How does MEP-driven zoning and space planning support occupant comfort through smart technologies?
I think we use these technologies while building large warehouses, and especially which are refrigerated. So I'm from the supply chain domain, so I will speak from that point of view.
Right.
So when we build warehouses, we make chambers for refrigeration, we make chillers and we make refrigerators and we make ambient zones. So ambient zone could be under between 18 to 21 degrees. Chiller would be like plus 5 degrees, and freezer could be anywhere between minus 18 to minus 50, 55 degrees. Used for various kind of food products like poultry, meat, and chillers used for vegetables, milk, eggs, and these things. So you have to be again, I would say, use softwares which will show you the heat maps, that what are you going to keep where, and how that software will tell you that, given your current business, current product mix, what kind of chambers you need. So we have these designing software. I don't know what you call them, but they will understand your product need, and so I may end up making a design which is either far exceeding my, say, refrigeration requirement or far exceeding my chiller requirement, and whereas my need is not that so much. So when they are doing the automated design, they will also create chambers which can be converted from frozen to chill and from chill to ambient. And same way, reverse engineering is done to create ambient into chilled and ambient into frozen, so that you have multiple uses. So these software also show you hotspots of activity even when the operation is going on. So when the operation is going on, the software will give you an alert saying that, hey, there is a leakage of energy from gate XYZ, or in this XYZ area, while your rest of the warehouse, I mean, we have very large warehouses. It could be 1 million square feet. It could be 500,000 square feet. So very large facilities. So, it tells us that, there are some hotspots developing where the temperature is going below the tolerance level or above the tolerance level. So all these automations are done, in designing these facilities to use optimal energy to maximize our usage required for our own use. And so many times, you will end up saving 15, 20, 25% energy, if you're really optimizing all these things. So really, technology is very useful. We have sort of AI chatbots giving you messages that how you can improve your operations, how you can chatbots are sitting on top of my WMS, on top of my DMS, on top of my I don't know what is the technical term for this, but the sort of chilling management system or the cooling management system. Something like you have a BMS, building management system. Same way we have chilling management systems connected to IoT. So not only my building is connected, my trucks are connected, and the moment anything goes beyond tolerance, I get SMS. I can design to give WhatsApp messages. I can design to give emails. I can design it. So on the fly, it is connected to the internet. So the IoT devices will not just tell me that my warehouse temperature is rising beyond tolerance. It will also tell me in which chamber or in which zone it is rising, so that I don't have to go and search that, what's wrong, there is a leakage and what went wrong. It will tell me exactly in which zone, because I have like sensors all over the place. So, sensor number 24, go and look in that area, something like that, it tells me. So the chilling management system is automated and it helps me conserve my energy and maintain optimal temperature, so that sometimes in food and all, you have to be very strict, otherwise the FDA guys will inspect and they will check your records. And, I could be sitting on 500 tons of meat and they will reject everything, throw it away. Why? Because in the past 7 days, there were temperature variations on which you did not act, you did not take action. So it could be a huge financial loss as well. So all these new software, help us do our business more efficiently and properly. And when we tell customers that we have these automation softwares in our facilities, they also feel confident that yes, our products will not spoil and they will be maintained as per law. Even there's a FTA law, Food and Drug Authority of I work in Dubai, so there is a UAE Food and Drug Authority which have modeled their laws over Singapore and US, so they are extremely strict. It's not as if that you could just do anything and get away with it. So, we have to follow the law, otherwise the consequences are very, very, can be, I mean, I could get fined 1 million dirhams, which is almost like what, 3 crore rupees. Yeah.
Wow. That's a splendid technology you are utilizing. And sir, now we are coming to the end of the session. Mr. Shailen, I would like to ask one more thing. You are in the supply and distribution.